All right, so we're going to talk about density curves and normal distributions in this particular chapter. In general, what I want you to visualize or think about when we were referring to a density curve is basically you can kind of get the idea from this particular graphic here. We decide that we want to use a curve to represent the data. So we're kind of just drawing an overall general shape to kind of cover or show the overall shape of a histogram. So it tends to be easier to look at things if we've kind of smoothed out all of those curves, that type of thing. So if you notice the way this curve has been drawn in, there's a little bit of extra here that is outside of the curve, but it basically takes the place of all of that that's missing on the inside here. So anyway, we use the shape of this curve, we draw the curve then to represent a particular set of data, but think of it as an overlay of that particular histogram. So you can still kind of visualize the idea of where that histogram is or what the shape of that histogram would be. We have some general properties or some guidelines that we are going to discuss that have to do with density curves, and then more specifically about normal density curves or normal distributions. So I want to share some of that with you. Because it's a normal distribution, in other words, because it's symmetric, so one of the things is that we will use mean and standard deviation to represent or to explain or to describe the data. Use mean and standard deviation to describe. We know because it is completely symmetric that the mean is equal to the median. And we also know that the standard deviation is what we're going to use to show the spread. Right? The measure of center that we are using is the mean, and the measure of spread that we are using to represent it is the standard deviation. We know that this graph is what's referred to as bell-shaped. It's considered a normal distribution, and it's single-peaked, right? There's just the one, so in other words, it's unimodal, but another term to use in this context is that it is single-peaked. And the beauty of talking about this in terms of area, or the curve, is that we can talk about the area under that curve. And so for convenience sake, because we are going to start talking about percents or proportions, we say that the area under the curve is always equal to 1. Area under curve equals 1. So that way, if we start talking about shading a particular part of this curve, we can talk about it in terms of something as a percent or as a proportion. So that's the beauty of saying that we know that the area, we want it to be equal to 1. Okay? So those are some ideas of the general idea of a normal distribution, right? And so when we are talking about these normal distributions, as you know, we consider the mean, and we know that's going to be right in the middle there. And that's what we use to show the mean or represent the mean. In this case, we're going to use that mu again. To show the standard deviation, notice the way this is drawn. This is drawn from the mean out to a particular location, and we draw a line going down. This is the distance of our standard deviation. And so on this particular graph, similar idea. Here is our mean. This is a lot tighter. There's a lot of data there right in the middle. It's a lot tighter. There's not as much spread clearly as there is in this one. This has got quite a bit of spread for our standard deviation. This one is very high and tight. Okay, we're going to take a quick side note. We're going to mostly be talking about normal distributions, but I want you to think about the fact that just as if these were histograms, we can talk about finding the mean and the median for a density curve if it is skewed, just as we could for a histogram. So remember what we did to find our mean and median. Quick reminder, for our median, we found our equal areas point. Remember, we drew our line to show where we think that there's just as much area to the left of that particular line as there is to the right of the line. That's our median. And then for our mean, remember, we are looking for that balance point, and this is the one that's not quite as easy to see or visualize. But they're kind of trying to show you here with this fulcrum point, once again, it would obviously weigh too heavy there. We have to shift a little bit, and so we're trying to find that point where this would balance. And then another quick reminder, remember this graph is skewed right, that histogram would be skewed right, so this density curve would be considered skewed right. And so that is why, if you notice in this particular graph, the mean is to the right of our median. So the long right tail pulls the mean to the right. So that's another concept to kind of think about or consider. We're going to look a little bit on this next page. I'm going to talk to you about what we call change of curvature for finding standard deviation. If we are given a normal curve, which majority of what we're going to look at in this particular section will be normal curves. So when we are looking at these normal curves, we want to be able to look at or determine where the first standard deviation would be from where the mean is. So we do what's the process that we use to try to find that where that standard deviation is we call this change of curvature. The way I like to think about doing this is that we're always going to label, sorry, I'm getting ahead of myself. We're always going to label where our mean is. And then we're going to draw a line going out from the mean out to where that line is, where our change of curvature for our standard deviation. Change of curvature to show standard deviation. And I'll show you examples here in just a second. So we know that our mean on this particular example, on this particular graph, we know our mean is right here, and I didn't do a real straight job there. In order to find the change of curvature or where our standard deviation is here, it's a practice type thing as well, just like it was with our means and medians. But you're going to draw, what I want you to visualize, or what I want you to kind of conceptually think about doing, is trying to trace the shape of this curve that's going down. So think of it as a parabola that you're kind of trying to trace or shape the shape of the curve going down from the top, but then also from the bottom in either direction, tracing from down low and tracing that part of that particular parabola. And what you're looking for is where those two parabolas basically would meet, where they intersect. I will tell you that in some instances I seem to draw better and find it better drawing on the left-hand side, and sometimes I draw it better on the right-hand side. So for me personally, I tend to do a little bit better job drawing on the right, but you need to practice on both sides just to kind of see where you think that point of intersection is, where they are. The two curves are intersecting to create the full shape of that curve. So approximately right here is where those two curves are intersecting. You can find it on one side or the other. You don't need to do it on both, although it should be consistent on both sides. And then to show the standard deviation, we draw from the mean out to that particular place on the curve, and we label that with our little sigma and say that that's our distance of standard deviation. So as I said before, it's a process of kind of practicing and doing quite a few examples just to kind of practice the technique. and seeing whether you feel like you are more consistent or more constant with how you are drawing your curves and how you're finding your change of curvature as to whether or not you're doing a better job drawing it on the left or on the right. And as I said, I tend to draw it a little bit better or a little bit clearer when I'm drawing on the left-hand side of the curve rather than the right-hand side. Maybe because I'm right-handed, I'm not quite sure. What I want you to notice is that if you look at any given curve and you think about kind of this distance along this curve, the tendency for a lot of people is to want to just kind of find where it looks like the middle of that distance would be, so approximately right there, so that you have the same amount of area to the above and below. And that's not really what you're looking for. I will tell you that if you tend to think of it that way, your standard deviation, your distance for your standard deviation is going to be higher than that. And so that might be a way of kind of helping you think about or visualize. Once again, this is one of those things where there's going to be a range that I would find acceptable. We will practice with this quite a bit. You're going to do a Nearpod here in just a minute to practice with this as well. Yeah. But it just takes practice, and there's going to kind of be a range of values that I would find acceptable. We just have to practice with that a little bit, okay? I'm going to show you this one example, and then you're going to do that Nearpod to kind of try and practice with this, and then you have other notes on the empirical rule. So let's take a look at this example here. So if you notice in this example, it says the height of these oak trees is normally distributed. The normal curve shown below represents this distribution. What is the mean? So our mean is right here in the middle. So our mean in this case is 90. And then it says estimate the standard deviation. So we need to do our change of curvature. So we're going to kind of draw our parabola pointing down. We're going to draw our parabola. Let me change colors. Draw our parabola pointing up. And I'm not quite intersecting, but I would say approximately right here for my standard deviation. And we need to look at what this distance is. So if we're at 90 and this looks like this is at a distance, this is at 87. So our standard deviation is approximately 3. I would probably, for this example, I would probably accept anywhere between 2.5 to 3.5. If you were much lower than that for your standard deviation, in other words, much higher here or lower here, I would not accept that. So I'm looking for that mid-range where you have an interval that is acceptable.